I'll just do a little review in case you missed class or need a review. One thing that we have been talking about is complex numbers, and complex numbers can be plotted on the complex plane, and the coordinates are x and y. So sometimes we call them x plus yr, x plus yi. But if we want to write this in in polar form, well, we know that in polar form we have the equation x is r cosine of theta, and y is r times the sine of theta. So x plus yi could be rewritten as r cosine theta plus I times r sine theta. And what we normally do is pull out the r. So we have r cosine theta plus I times the sine of theta. And if we're feeling kind of lazy, we can call this r cis theta, right? So cosine plus I sine the theta. The other thing that you discovered yesterday was that if you have complex numbers, they can be kind of a pain in the neck to write. So one thing we could do is put them in polar form. And if we put them in polar form, then we have this nice little shortcut. Suppose one is, let's say, r sub 1, let's say cis theta. We have another complex number in polar form. That might be r sub 2 cis beta. And there were two things we noticed. One is that when you multiplied them together, so this is times, when you multiply them together, that becomes a really easy operation. That is going to be equal to r1 times r2, and we're going to do cis theta plus beta. So we multiply the radii and we add the angles. The other thing that we had spoken about is that if we're dividing, it's similarly kind of easy. We're going to have r1 over r2, but then we're just going to subtract the angles. And finally, what we talked about today is really an extension of this multiplication principle, and it's called DeMoivres Theorem. So for DeMoivres Theorem, if you have a complex number written in polar form, and you would like to raise it to a power, here's what ends up happening. It's the r value to the power, but then we're going to, this is a times, multiply, oops, let me fix that. This should be cis. Multiply that by n times the angle. So if you had something like this, suppose you had 1 over square root of 2 plus I times 1 over square root of 2, and you needed to raise that, let's say, to the 10th power. Well, that would be fairly hideous. However, you know that in polar form, the r value here is 1, the angle is 45, so I could just call this cis 45 degrees. However, if I'm going to raise that to the 10th, well, my r is 1, so I'm going to have 1 to the 10th, which is not going to make one little bit of difference, but then I'm going to have cis, well, 45 times 10 is 450 degrees. From that 450 degrees, I'm going to subtract 360 because you know we have already gone around the circle. So this is going to leave me with cis 90 degrees. And what I know is that this is really going to be the cosine of 90, which is 0. And I'm going to have I times the sine of 90, which is 1. So this just gives me I. So isn't that quick? Instead of writing this whole binomial out 10 times, I can just use DeMoivres theorem, and I end up with this nice, simple answer of I.